Okay, hi guys, so let's continue on seeing some more examples on Cannizaro reaction. Okay, so we have the first question is, which of the following compounds will not undergo Cannizaro reaction? Okay, so I'm not writing it, so maybe we can directly tell. So we have something like CCl3, C double bond OH. Okay, in basic medium we are heating it. Second is, if we have something like, again basic medium, heating it. C is CH3, C double bond OH. Okay, and D is all. So which of this compound will not undergo Cannizaro reaction is the question. So what would be the correct answer? So let's see. Will this compound undergo Cannizaro reaction? No. Why? Because when you react it with OH minus, first leaving group would be this one. Okay, as a result you would be getting CHCl3. Okay, so there is no scope for any nucleophile attacking on the another aldehyde. Okay, in this case again OET minus will be leaving. Okay, when actually what will happen is, in the first step we'll be getting something like this. OH would be getting attached at this carbon position, then we have OET, then again when we are actually having a double bond with this carbon atom, we'll be getting something like this. Okay, and OH here, sorry, and we'll be getting this as the leaving group, OET minus. Okay, so OET minus again would be not attacking on the another compound, which is ester. Okay, why this will not take place in Cannizaro reaction? Because of presence of alpha hydrogen. In Cannizaro reaction the condition was alpha hydrogen should not be present. Okay, so the correct answer would be all. None of this would actually be presenting or taking part in the Cannizaro reaction. So next let us take a look at cross Cannizaro reaction. Okay, so first example we have is, suppose we have HC double bond OH and we are reacting it with PHCH double bond O, and in basic medium, and we are heating it also. So again what will be the compound formed in this cases? We will have something like HC double bond O 1 minus plus PH CH2 OH. Okay, and second one we have HC double bond OH plus we have something like this, providing basic medium, heating it. So what will happen in these cases? So we'll be getting something like CO2 minus plus, this is the compound. So just keep this point in mind, that whenever a formaldehyde is present among the or between the two groups which are present in the reaction mixture and undergoing heating with the basic medium, please remember that oxidation of the formaldehyde or the formaldehyde group will actually take place, and the reduction of the other group will take place. Why? Because this is actually be more delta positive than this carbon atom. Okay, or on this carbon atom, hence OH minus will prefer attacking on this carbon atom. Okay, so just remember this, that in a cross Cannizaro reaction, if one of the reactant is formaldehyde, then oxidation of formaldehyde, will take place, and reduction of another aldehyde will take place. Another one will take place. Okay, and also Cannizaro reaction, or rather cross Cannizaro reaction, is an example of redox reaction. Okay, so if some of you guys are not familiar with the redox reaction, don't worry, you can find that in my inorganic chemistry video lectures, but I hope almost all would be aware of this term. Okay, so next, going with the next topic, which is production of carbonyl. Okay, so we have this aldehyde group and we have a glycol. Okay, what will happen is, when we pass on acidic medium onto this reaction mixture, we'll be getting something like acetal. This is acetal. Okay, let us actually look at the mechanism of this reaction. What will happen is, this aldehyde in acidic medium will convert itself into positive H, and then what will happen is, when we are passing glycol in the reaction mixture, this OH will attack this carbon atom, so we'll be getting something like OH attached here and O. Obviously this bond between O and H will break itself. Okay, so then after this, again in acidic medium, what will happen is, this oxygen atom will be attacking on this H plus, and as a result we'll be getting that O plus, H and H here, and something like this. Okay, then next what will happen is, this water molecule will break its bond with this carbon atom, creating a carbocation here, and then this oxygen atom would then be attacking on this carbon atom, and as a result we'll be getting something like O, C, C, O, and both O attached to this carbon atom. Okay, so this is what is known as acetal. Okay, let's look at another example. So we have something like this compound. Okay, and again we are reacting it with glycol. This is glycol. What will happen is, obviously, as this carbon atom would be more reactive, as it is having more partial positive charge, unlike the keto group, so we will have something like this. Okay, now when we react this compound again with, let's say, CS3 MgBr Grignard reagent, and second we are passing H plus medium and hydrolyzing the compound, we'll be getting this CS3 minus will be attacking on this carbon atom, and as a result O minus would be getting formed in acidic medium. Again we'll be getting this as the final product. OH here, CS3 here, and what about this group, or the acetyl group? What will happen here is, in acidic medium, what will happen is, cleavage of C and O bonds will take place, and as a result we'll be getting again two OH attached to the same carbon. Okay, which will result it into the compound again forming a aldehyde group at this position. Okay, so this would be the final product. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the same topic, and then we'll be moving on to test for aldehydes and ketones. Okay, till then, good luck and goodbye.